Class 10. Today we have to learn about covalency. What is covalency and what is the property of covalent bond? Okay. In this class we have to deal about the different aspects of carbon atom. What is covalency? What we call covalency. Like in earlier classes, we already have learned that valency of any element actually represents what is the outermost structure of any atom is. Is that atom has the ability to accept extra electron to fulfill its octet, or have some extra electron 1 or 2 or 3 so that it will try to release its electrons to become chemically less reactive or chemically stable. Generally, what happens in any non-metal, if you have 4 electrons in your valence shell, then it is very hard for you to connect with other element, especially by using your ionic bond, because giving electron, all of your valence electron, all 4 electron, or accepting extra 4 electron is actually very highly energy required process, and which is not performed by any element, especially when its valency is around plus minus 4. Okay, in that case they actually involve another type of chemical bonding which we call covalent bonding. In the covalent bonding, no energy required or no extra effort gets required in this type of bonding. So here valency comes into another form. Valency actually represents what is the electron donating or accepting nature of any element. But what is covalency? Covalency is actually represents what is the total number of electron which an atom is gonna share with another one atom to make a covalent bond. Okay, it is explained as the total number of valence electrons that an atom have to share with another atom to form a covalent bond. So covalency determines the ability of any atom, and actually it represents you the total number of electron which is gonna involve in the process of the formation of covalent bond. So in covalent bond, actually electrons get shared between 2 or between 3 or between 4 atoms. How this happens? It happens because of their outermost electrons. They get shared either in 1-1 or in group of 2 or in group of 3. So covalency represents how much an atom has the ability, how much an atom of any element has the ability or the number of electron that it is willingly share with other atom, okay, or molecule. Like an example, hydrogen has 1 electron, just 1 electron that it can share or it can transfer. So generally the covalency of hydrogen will be 1 because it has just 1 electron to make covalent bond that it actually makes with another one hydrogen atom. Hydrogen, it forms H2. In the same way, oxygen has 2 electrons actually that it can share with other atom. So you can say, like, to form oxygen bonding, like to make O2, each oxygen atom will share 2 of its electron. So the covalency of oxygen will be there 2. In the same case, if there is nitrogen, the nitrogen has the ability to share 3 of its electron. So if nitrogen is gonna combine with another one nitrogen to form nitrogen dinitrogen atom or diatomic molecular form of nitrogen, it will usually use 3 of its electron. 3. So the covalency of nitrogen will be 3. So you can see here the covalency represents you the number of electron which an element actually permanently have, and that actually electrons comes into action when they get shared. So that total number of shared electron is actually represents the covalency of the element. Okay, so let's get over from all this and let's talk about the property of covalent bond. What is the property of covalent bond? Like in ionic bond, in last classes we already have learned that when any atom transfer its electron, it becomes chemically very active or say reactive. Like ions have a high melting point because of the strong attraction and repulsion between similar and opposite charges. We all know that actually if an atom transfers its electron, it becomes positively charged, and if any atom accepts the free electron or electron from another one atom, then it becomes chemically negatively charged ion. So in the case, they very strongly attract each other. In the case, you need lots of energy, excessive energy to break them apart, to separate them. That's not the case in the covalent bond. Covalent bond has some different properties. What are those properties? Let's see. First of all, its physical state. Look, we already have learned that in ionic bond, generally we see those ionic bond in the form of different types of salts. All the types of salts. Sodium chloride, magnesium sulfate, calcium carbonate, sodium nitrate, ammonium sulfate. So there are varieties of salts, or maybe the varieties of ionic bonds that exist actually in different compounds. There you can see two different ionized charged spheres, positive and negative. But in covalent bond, that doesn't happen. In covalent bond, electron gets shared, and that sharing of electron actually creates them differently. That's why if you see ionic bond and covalent bond in two different substances, they both will appear to you in different cases. Like almost all the ionic compounds can exist in solid state. But in covalent bonding, that doesn't matter to exist in solid state, because most of the covalent bonds or most of the compounds which have covalent bonding in common exist in gaseous state. Most of. So like all the things that exist, generally hydrogen, chlorine, oxygen, all these gases, generally all the gases that we know exist in gaseous state. And all these gases have one thing in common, that is covalent bonding. One element is just there which is in liquid state and have covalent bonding within its molecules is bromine. Just bromine is the molecule of two bromine atom which exhibit liquid state, which is the physical state of bromine, and have covalent bond between two bromine atom. And some exceptional elements which have covalent bonding but also they exist in solid state. Example, iodine and phosphorus and sulfur. So in covalent bond there are varieties. You can find covalent bond in three of the state of matter: in solid state, in liquid state, and in gaseous state. But mostly covalent bonds exist in gaseous state. So that is what happens if any atom share its electron with another one atom. Then it decides what type of physical state they would acquire, whether it is with solid or liquid or of gaseous state. Now the second property of covalent bond, and that is called melting and boiling point. Melting point and boiling point. What we already have seen in ionic bonds, that because of the highly charged spheres or between two different charged spheres or two different charged bodies or two different charged molecules or two different charged atoms, because of plus and minus, they have the strong attraction, and because of that you need extra energy, but not the same acted in covalent bond. In melting and boiling point, if you see that they have low melting point and low boiling point, since they share their electron, and because of the sharing they need some extra push, just an extra push of energy, or just the supply of some extra energy, so that they can break apart. And that's why we can easily break them by the supply of electric current in our fluorescent tubes. So you must have seen CFL, in which we inject some gases and also some different colorful tubes. Actually, gases can be easily broken out by the supply of electric current or electric discharge, but at the same time all the covalent bonding have actually less power to attract each other. There's an exception, and that is diamond. Diamond is actually very strong. In the natural state, if you see, then diamond is very strong, having covalent bonding, but not the same happens with all the covalent bonded molecules. Generally they have low melting point and low boiling point, except that diamond, which has 4000 Kelvin melting point. That's very high, that's pretty high. Okay, now the third is conductivity. What we learned normally in basic physics, that all the current that supplies needs charges, any type of charge, whether it would be free electron or in electrolysis ionic molecules, ion molecules like sulfate ion or any metal ion or non-metallic ions. There should be the presence of ions or any charged subatomic particle or any particle. There should be free charges that can move. But in the case of covalent bonded molecules, there are no free charges. So why? Because all the electrons are actually being shared. So how, if no electron is being able to escape or no free electron is available, then how could you flow current through any covalent bonded substance? Like, there should be some ions. One exception is there, that is graphite. Graphite has covalent bonding, but at the same time one electron is there in covalent bond. In graphite, one carbon atom shares 3 of its electron and one electron gets free in a state, and that one free electron in the graphite conducts the electric current. So in conductivity we see actually almost all the substances in covalent bond becomes very repulsive to electric current, or say, and behave like insulator. They behave like insulator, except one, that graphite. So generally have no conductivity. Exception, graphite. Okay. Now the next is, we already have discussed physical state, melting and boiling state, conductivity, and now the reaction. If two non-metal gets reacted with each other, they form something new. They form something very cleverly made substance. Like if you connect hydrogen and chlorine, both are non-metal, both will try to share their electron, and in turn they will provide you HCl, which is a liquid. Generally the combination of two non-metallic atoms provides you something which might be exist in liquid state. Like in another one example, if we have H2 plus O2, we can get water, which is also in liquid state. Generally this example shows that if you connect two different non-metallic atoms, then you can get something which is in liquid state. Okay, and these things actually show us different aspects of covalent property, or you can say these things are actually properties of all those materials which have covalent bond in common. Okay, so in this class we are done. In the next class we will learn about some allotropes and their different properties. Okay, up to this we are done.